most important section of Docker, which is Docker networking. We have talked about all the configuration, what Docker is, how Docker is built, what containers are, what makes up containers, how to link containers, and all whatnot. We have talked about all those things. Today we are going to be entering into Docker networking, and while entering into Docker networking, we are entering into the industry practice of what actually happens with Docker. Okay, we are actually going into the real essence of Docker. So in the past, we have talked about various ways of linking containers. We talked about if I ask you how many ways are there to link containers, we talked about the first way was -- link. That was the first way to link containers. We talked about -- link. We talked about Docker compose. We talked about Docker compose, and we said -- link was already outdated because you cannot link more than 3 to 4 containers with -- link. So it is just something to test your small containers. It's already outdated. And then we talked about the reason of bringing Docker compose. Docker compose from time to time is still being used, but in essence, the real industry heavy level, you cannot use Docker compose, because these guys in the interview sessions, they like asking this very question: why is it that you won't go for Docker compose, but you won't go for -- link, but you will go for Docker compose? Why? They will always like asking you those type of questions. So when you receive those type of questions, you should be able to criticize -- link correctly. I mean, give the shortcomings of -- link, and then also give Docker compose, and also give its own shortcomings. And now we are entering into the third way by which containers are connected, which is called Docker networking. Now in Docker networking, this is the only way you can connect unlimited number of containers. This is the only way we are going to be connecting unlimited number of containers. So if there are as many containers as you can create, you can connect all the containers with Docker networking. Okay, so what we are going to be looking at today, we are going to be understanding what Docker networking is all about. Okay, and then inside Docker networking, there is a type of networking called Docker 0. So we are going to see Docker 0 and know what Docker 0 is all about, and then we look at the drawbacks of Docker 0. How Docker 0 is primitive. What makes Docker 0 that primitive? And then if Docker 0 is primitive, what comes to solve the primitivity of Docker 0? We are going to be creating custom networks which will solve the drawback that Docker 0 is creating. Okay, and we'll create custom network. We'll come out from there now, and we'll see why we have to create those custom network. Why should we create custom networks? Okay, and then we'll see the different types of networks. There is Docker 0, which is a type of network. We are going to see whether Docker 0 belongs to the bridge network, the host network, the node network, or the overlay network. You should be capable of defining all these networks and saying how they occur, where they occur, and why they are there the way they are. You should be able to explain all these networks. Okay, what is a bridge network? Give an example. What is a host network? Give an example. What is a node network? Give an example. What is an overlay network? Give an example, and say where they are being used. So our lesson of today, guys, I did a lot of research into this lesson. I doubt whether it is something that you can find in the internet, because I actually consulted some other elderly guys in it. So take great care. I will give you all the notes. I will give you a note. Don't bother. I'm not giving you the notes now, because I want you to make your own notes. While making your own notes, you learn 10 times more than when I give you all the notes. At the end, I'll give you all the notes that I'm using here. I'm going to give it to you. Don't think that I'm being stingy with notes. I'm not going to remain with the notes. I want that you should follow from the video, and from the video write everything that is there, because when I give these notes to you, it is kind of, you just go and copy and paste. I can be copying and pasting during classes. After all, I'm the one that made the research, so I can be copying and pasting. But you at home, is better you type the commands yourself. Type the commands and see how they occur yourself, okay, rather than copying and pasting. When you copy and paste like that, you forget a lot of things, but when you type your command, you become very useful. So that's the reason why I'm not giving you these notes as the videos are coming. All right, so let us begin. The first thing we are going to learn today is Docker networking. So what is Docker networking? What exactly is Docker networking? Okay, for example, if we did something that we call ping, that means that what? I create a container here, and then I create another container here, and then I ping this container. I use -- link. I link the two containers. Then when I link the two containers, then I ping the containers, right? When I create the two containers, I then ping the containers. Okay, when I ping the containers, now I see a communication that is established between these two containers. That is what we know. But this happened after I must have done -- link, or I must have done Docker compose. Okay, that is how it happens. But now we are bringing the idea of Docker network. In Docker network, we are not going to be using Docker compose anymore. We are not going to be using -- link anymore. We are going to be using a characteristics of Docker, which says that every Docker container comes with an IP address. Every Docker container comes with an IP address, and that IP address is in the form, I think, 1.7.2, something like that, and then you have some .0.0.0, and you have the rest. So every Docker container comes with an IP address, and it is from this IP address that we are going to establish a network. It is from this IP address that we are going to establish a network between two containers. So let us come to our console and see what we are going to do. The first thing that we are going to do is we want to run an Nginx container, and then inspect the Nginx container. Okay, when we run this Nginx container, we are going to inspect it. So let's come to our console. First of all, we create our computer. Yes, Adija.
So you wanted to copy it, but you do not copy all the words.
All the words for?
It's like you were copying the words for Nginx, but you do not copy it all.
No, I'm not yet creating this one, right? I'm not yet creating. I'm still trying to create the machine.
Okay, sir.
Yeah. Let's create our instance. Let's just create one instance. Okay, we have our instance created. Generally, we have to install Docker in our EC2 instance. Okay, we create our this is our Docker script.
What about the command bin bash, sir?
What does that command do?
To tell the Docker daemon that this is a shell script.
Is that exactly what that command does? Who knows what the command bin bash does? And when we use it? Okay, you are not wrong, you are right. You can always start with a bin bash, which is but normal. That bin bash actually tells a container that is the language we are using, but most often it is in containers that are operating system based.
Okay.
Yes, containers that are operating system based, you always add bin bash to them.
Well, it's my first time to see a shell running without bin bash, so I never knew it could be like this.
No, it runs. It does run. Okay, our Docker version is ready. Okay, so now what we do is let us install Nginx. We are installing Nginx in detached mode, and we are auto binding the ports. Okay, the very first thing I want us to do is let us look at Nginx and see the container IP. Look at something here. Every container that is installed must have an IP address. Every container that is installed must have an IP address, and in order to get the IP address of that container, we have to do docker inspect. Now this is the port that was bound to the Nginx container. So let us inspect the Nginx now to see the IP address of Nginx. We take the ID of Nginx, and then we inspect it. To inspect a container, I hope we know this, docker inspect container ID. Container ID, we are inspecting the container. Now look at what I am seeing here. Look at the IP address. This is the IP address of Nginx. So Nginx as a container has an IP of its own. It has an IP of its own. Like this host machine itself has an IP address. Nginx have an IP address of its own. Okay, so if Nginx is having an IP address of its own, what is the use of this IP address? How can we use this IP address? How should we be able to use this IP address of Nginx? Now we are told that every container must have an IP address, right? Every container have an IP address, and you can take note of the IP address, the internal IP address of Nginx, which we have there. What is our internal IP address here? Here it is. This is our internal IP address of Nginx. Okay. Now we have this IP address of Nginx. This IP is not the same IP address like the IP address of the host machine. No, it is not. How did Nginx get this IP address? What gave Nginx the IP address? By default, when any container is installed, there is a default there's a default IP address assigner which is built inside Docker, which is called Docker 0. Docker 0. Docker 0 is the default IP designer that gives IP address to all containers, which means if you are creating a container, that container will be given an IP in the range of Docker 0. Docker 0 gives this IP address to all containers so that containers can communicate within themselves. And how do containers communicate within themselves? How can this container, which is created with a Docker 0, communicate with this container which is created in the Docker 0 network? So we say, where are your containers created? They are created in the Docker 0 network. So if they are created in the Docker 0 network, how should they communicate? So let us see. Here, when I was preparing your notes, you try this. You create the second container. Okay, create another container. Let's call this a Redis container. Let's create a Redis container. What is Redis? Redis is a small Unix container, right? A small Unix container that runs on Linux. Okay, you create a Redis container and have two containers created. Okay, our Redis container is created. Now let us try to see the ID of our Redis. Let's look at the ID. Here we have our Nginx. Here we have our Redis, and this is the IP of our Redis. Okay, that's the IP of our Redis. Let us inspect that IP. ID, please. Now, this is our Redis created. This is its IP address. Look at the IP address of Redis here. We have 03. Okay, 172. All the IP address will be 172.17, then a particular number. For Nginx, it was what? 172. Where do you have Nginx?
1701.
1701.
Yeah.
You sure? Here is Nginx. Let's look at the IP address of Nginx. This is it. It was 02.
Okay.
172.17.02. That's the IP address of Nginx, and then that of Redis is 03. Right? You see that Docker 0 is, if we create another container, its own IP will be 04. It will be 172.17.04. Right? So Docker 0 will classify its containers in this range of IP. Okay. The question now is, can we communicate from Redis to Nginx? That is our question. Can we be able to communicate from Redis to Nginx? Redis is having the ping utility. If we enter the Redis container, can we ping Nginx? That is our question. That is the question that we should be struggling to look at. Can we enter the Redis container and ping Nginx? So let us see. So let us try to see how we can get in there and see how, if we can actually ping Nginx. They say, now can these two containers communicate with each other? To check whether containers can communicate with each other or not, let's create BusyBox container as it contains ping utility. Redis does not have the ping utility, please. If we try to enter through Redis, we are not going to have that ping utility. So let us use BusyBox, because the BusyBox have a ping utility. When I was preparing your notes, I was hooked, and when I went to find out, I discovered that Redis is not coming officially with a ping utility, but BusyBox comes with a ping utility. But you will still be able to communicate with all of them, right? With the same manner. If you install the ping utility, I don't want us to take that time to be going through installing using ping utility and all the like. So let us create a BusyBox. Now this is what we are going to be creating with BusyBox. We are going to run a BusyBox container. The name of our BusyBox container will be tester1. Okay, and we are going to run BusyBox 1.28, and we are going to add a tag to it. It should sleep after 3600 seconds. That means the BusyBox should go to dormant state after 3600 seconds. Okay, when we run this container, a BusyBox will be created. Let us run it. Okay, our BusyBox is created. Next, let us look at its ID address of BusyBox. This is the IP address BusyBox. That's it. So that is its ID. So we put the ID there. So we take note of the ID of BusyBox. Okay, now now this is Redis, this is BusyBox. So let us look at the IP of Redis. Where is Redis? It is Redis. Copy Redis. Okay, now we want to exec into BusyBox and ping Nginx. Okay, we want to exec into BusyBox and ping Nginx. We are execting into BusyBox, and then from BusyBox we are going to ping Nginx. Take care of this language, please. We are execting into BusyBox, docker exec BusyBox, and then we are going to ping Nginx, and we are going to see whether it is going to work. What are we expecting? It should not work. You see, ping, bad address. Okay, bad address. We'll see why it will not work, and we'll explain why it is not going to work. I'm giving all these failure addresses so that you should know and know why. If you get a failure, this is what is happening and this is where it is happening. It didn't work. All right, it is not pinging. All right, so with Docker 0 network, we cannot ping with container IDs. You do not ping with container IDs, no way. Okay, so what you do is, let's try to ping with container name. Let's try to ping with container name. Let's look at the container name for Redis. What's the container name for Redis? This is a container name for, where's my container name for Redis? That is BusyBox. Where is our command? I want to try and see if we can ping using the name for Redis. This is for BusyBox. This should be for okay, we did not give the name for Redis, right? We ran Redis without giving its container name. So let us run Redis now and have a particular, because we ran Redis here without allocating a particular name for Redis, which is not something that is better. So let us give a particular name for Redis. I think in my notes, that is what I prepared as a name for Redis. So let me give a Redis container down here. So I take don't get confused with my scrolling up and down. Okay, here. Okay, to give a name to a container, what do we write? Hyphen name, and then we take this one Okay, if we run now this command, docker run -name and then -d-p redis. Okay, so let us first of all remove redis. Good. We discover that there is no more redis there, so we run now this command. Okay, our redis is there very well now. Okay, this is the name of our redis. That is our name now, very well. Okay, so we try to see how we can ping redis to our busy box. Okay, by name, pinging by name. Okay, in this case we are going to exec into our container, into our busybox container, and then we try to ping redis. Okay, let's exec into our busybox container. What is our busybox IP? We exec into our busybox IP ID, and then we ping our redis. What are we expecting? A failure or a pass? We are expecting a failure. Bad address determined here, right? Why is that failure? Let's come and see. It is not pinging. Why? Docker 0 network, we cannot ping with container name, so we are not able to ping with, the first one was container ID. We could not ping with container ID. The second one was, first one cannot ping with ID, cannot ping with name, container name. You should know this very well. Cannot ping with ID, cannot ping with container name. So because they will ask you in an interview question, in an interview, try to link a connection between this. Use an ID, use their ID to link. They will just ask you, use an ID. Can you use an ID to link the two, to ping the two containers? No. In Docker, if they are in Docker 0, they cannot. Okay, and if they say, okay, what about the name? You say no, in Docker 0 you cannot ping using their names. Okay, because these guys like always trying to make you look stupid. Okay, so let's try now to ping with IP address. Okay, let's try to ping with IP address. Let's take the IP address of redis, and then we enter inside busybox and ping with the IP address of redis. Okay, how do we get the IP address of redis? Let's run docker inspect, then the ID of redis. You run docker inspect, you put the ID of redis, and then you get the IP of redis, and then that is what we are going to be using to ping. Okay, that's what we are going to be using to ping to our container. So we change the ID of this to the ID of Redis. This is our Redis. No, we are supposed to enter our busy box, then we ping our Redis. Okay, where are we? Okay, we enter the IP, the ID, we enter through the busy box, and then we ping Redis. We can see clearly that you are able to ping Redis. What is our conclusion here? What is our conclusion here? Our conclusion is that you can only ping through the container ID to another container IP. Take note of this conclusion very well, please. You can only ping through the container ID to another container's IP. That is Docker networking. If they say establish a connection between two containers that have been installed in a Docker 0, the connection that you are going to establish is pinging from container ID to container IP. That is the conclusion that we are making here. You will only be able to ping from the container ID to the container IP. That's the very first thing you should know about Docker 0. That is how they are being made. So we can create as many containers as possible. All the containers will be created inside Docker 0. All of them will be created inside Docker 0, and we can be able to interconnect with all the containers very well without any problem. So automatically every container that is created is given an IP address, and that IP address belongs to Docker 0. Okay, now the question arises: if all containers are created and IP addresses are according to Docker's containers by Docker 0, and the story is this sweet, why saying that Docker 0 has a drawback? And if it does have a drawback, what is the solution of that drawback? Okay, now there is an aspect with containers where the IP address that containers have is not permanent. Their IP addresses are not permanent. Imagine that you have a container here. Just imagine that you have a container here that has an IP address of let's say this container have an IP address of 172.168.1.1 2.0.2, and after you come back, you have paired these two containers through a ping with this container name and this container IP. Then you shut this machine down, you shut the whole system down. You come the next day, you boot up the system. This container is not going to come up with this very particular IP address. The IP address is going to change. So IP addresses of containers are dynamic. IP addresses of containers are dynamic. The first problem is containers have dynamic IPs. That is the first reason. So if containers have dynamic IPs, what is the issue with containers having dynamic IPs? Yes, containers have dynamic IPs. So what? The issue is that you pinged with a particular IP address. That linkage is there with this IP address. Now the container has come up with a different IP address. Will this ping still be established? No, because there is a new IP address that has come in. And then now imagine a system in which you constructed. There is a back-end database, and that database had a particular IP address which it was communicating with the front end. It was communicating with the ID of a front end, and then the system comes up. If the system comes up, that means this middleware has to talk to the back end. And if it is talking to the back end, the IP is no more the same again, because it talks to the back end through the IP. If the IP changes, this man can no more talk to the back end. It is a new IP address. The link was created with an old IP address. It is now a new IP address. This man can no more talk. So the reason why Docker 0 is not good is because Docker 0 uses dynamic IP and it pings from ID to IP. So it is not a workable solution. If Docker 0 is not a workable solution, what then can we do? What then is the solution for it? The solution for it is what we now call custom networks. So what are custom networks? Docker 0 is a default network. That means it is the network that is there. It is there. That means without you creating, if you are creating a container without telling the container that go to this network, that container will automatically be placed in the Docker 0 network. But now what we usually do in the industry is that when we are creating containers, we always create the containers in a particular network, in a custom network. Okay, we create containers in that custom network. Why should we create the containers in custom network? Because in custom network, containers ping each other using container name, no more container IP address. I hope you get it. The container names are now used. The names are now used to ping each other, no more the IP address. So much so that if this container is rebooted, the IP will change, but the name of the container will remain the same. So the ping will still be established through the name of the container. So in custom network, we are pinging the two containers using container names. Okay, so let's see how this happens. So I kind of explain everything that is happening here, everything that I've explained to you here. I kind of put it in the notes here. Gave the problem with Docker 0, you get it. Gave an explanation on how the database and the middleware will have to communicate, and if there is lack of IP address, what will happen there. I kind of gave everything there. Then now So we said our hyphen link is updated. We can no more be using hyphen link. Okay, all right. So now in this type of a situation, we want to create our custom network. So let's delete all our containers that we have created. This is the command that Mr. Kiba found somewhere in the internet. I bet. Now the
I remember, sir.
Yes, this container, this command deletes everything. There is not a command to be using because it is very dangerous. Okay, deleting all our containers. Let us create. First, I want to create a new network. My network will be my name. I want to create a network called 1U. The command to create a new network is docker network create. Then this is the network name. Okay, docker network create. This is the network name. All right. So if I run this command, you see that is the network has been created. Okay, how do I know the network has been created? I can run docker inspect, right? I run docker inspect. This is my network. Okay, how do I know that it is actually my network? This is my name here. That means this network now belongs to me. That is a special network that I have created, and the network is just like Docker 0, but it is more advanced than Docker 0 because it is my own network. And I want in my own network, I would like that containers should be pinging each other using container name. Okay, in my own network, this is its own IP address series. Okay, that is its gateway. That's its IP address series. You get everything when you run your inspect. You get everything with your own network. Okay, now that we have created our network, okay, we have our gateway IP address series. Okay, can we add containers to our network? Yes, we can add containers to our networks. Well, how can we create containers in our network? Now look at this. We want to create the Nginx container, and the name of the Nginx container will be app. Now we know all these things. Docker run we know, -z we know, -p we know, hyphen name we know. The only thing we are learning now is -net this. So if they ask you, how do you do to create your own network? I doubt which type of interview they can ever ask this question, this type of a question. Then that person has really entered inside the internal core of Docker. What I'm treating to you now is the internal section of Docker. How to create your own network inside Docker. Even most of these guys in the industry, they just use default things and move away. But how to create your own network inside Docker? You use -net, and then you give the name of your network. Then now these containers will be created in your network, not more in the Docker 0 network. They will be created now in your network. Let us run it. Okay, our container has been created. Next thing is we have to make sure that this container truly is created in our network. Okay, it is going to be created. It has been created in our network. How do we do that? We have to run. Let us see if the containers that are running. Make sure that it is our only container that is running. It is the Nginx container that is running, right? It is the Nginx container that is running. This is the IP address or ID of the Nginx container. Fine, we have the Nginx container, we have the IP. So let us inspect the app. Docker inspect the app to see the IP address of the container. Okay, take note, we are inspecting now but what? The app, but at the first we were inspecting the what? The IP, the ID, but now we are able to inspect from the app, the name. Remember, we are inspecting from the name. When we were using Docker 0, we were not able to inspect from the name, we were inspecting from the ID. But when we are using our own network, we can inspect from the app. Okay, when I inspect from the app, what do I get? I get the IP address of my container. That is the IP address of my container. We copy our IP address. This is the IP address of our container. It's almost the same thing. Get the IP address of our container, right? Okay, now what do we do? Let's create one more container in the 1U network. We are creating one more container in the 1U network. Okay, here is the command: docker run -d -p -name my box. This is the name of the container that we are creating, and we are now passing the container to -net 1U, right? This is another, this is the accord of the container to a network, and we are giving the name of the container, the name of the image, and then we are asking it to sleep after 3600 seconds. That is the command that we are running. We are making sure we are creating a container in our network that we have just created. Container gets created without any problem. Now, as container gets created, let us see and make sure that we have the ID of the container. So this is the ID of our container. This is a busy box that was just created. This is the ID of our container, right? We have the ID of our container, and the name of the container is what? My box. Okay, the name of the container is my box. Okay, now I want to check if containers can be communicating using names. Okay, let's enter into BusyBox. We are going to enter inside BusyBox itself, and then from BusyBox we want to ping our Nginx. Let's try to see. First, in order to enter BusyBox, we are going to have to copy its ID as the ID. Mr. Kiba, I hope you see now where sh is coming. Sh is like a bash. Okay, docker exec it, we are entering BusyBox, and then we are specifying that we want to use bash. This is where that your statement came. Okay, we are inside the BusyBox right now. We are inside the BusyBox. Right inside the BusyBox, what do we do? Right inside the BusyBox, we want to ping. Okay, we want to ping. Let's get all the networks. If I run IPA, it's a Linux command. Okay, it will show the list of all the network adapters that we can see. Let us run it, and you see the networks that are there. Now look at what we have here. This is the first one that we have. This is the second one that we have. Okay, we have our two IP addresses that are there. So now, can we communicate? Can we have a communication? That is our greatest wish. Can we now ping each other using the names without any problem? Let us say ping up, right? Ping up. Can you ping up? Are you seeing? It is pinging. So it is pinging now using the name of the container, the name of Nginx. It can also ping using the IP of Nginx without any problem. So it is pinging, communicating without any issue. So we have now solved that issue of Docker 0 not being able to ping using the name, and here we are pinging using the name. And we can also ping using IP, but we don't want to ping using IP, we want to ping using the name because we know the implications of IP pinging. So we are pinging here using the name. So we have solved the issue of pinging using IP. Okay, so it will ping. So it says similarly we can also ping with container ID. In fact, when we use our custom network, we can ping with IP, we can ping with name, and we can ping with ID. Okay, so our custom network solves a huge bunch of problems that Docker network could have. Okay, so we are good and we are fine without any problem. To this level, any question? Yes, Mr. Kiba.
All right, sir. Now that we can ping using our, that is, once we have created our own custom network,
Yes.
we can now ping using the name of containers.
Yes.
What if you have to, let's say, we delete this session and we have to start a new machine tomorrow? Will this network still be active, or we have to create our custom network before running containers in?
Let me get your question clear. What if you are asking if we delete the container?
Yes, sir.
And then without deleting the network?
Like we delete the network and to start all over again, should we like make our own custom network before running containers again?
Yes. Each time you delete a network, then you have to come and recreate again that another network before you start running.
Okay, sir.
Because you cannot just come and run a container without a network and then you expect a custom network to come up. No. If you run that type of a container, it will be created under the Docker 0 network. The Docker 0 network is always there. You don't install it. You do not install Docker 0.
Okay.
That one is default.
Okay, yes. Okay.
Now we are moving into another session, and we are saying that what if there are some containers that we are already created under Docker 0, then you came now and then you created your own custom network. Is it possible for you to take those containers that we are already created under Docker 0 and add to your own custom network? That's the question that we want to answer. Which means there are some containers that we are already created under Docker 0. Now we want to take those containers and add to your own containers in your own network. Can that be possible? Yes, that can be possible. Let us see. Look at something here. Let us create a Redis. When we are creating like this, what will happen? Where will it be created? Of course, in the Docker 0 network. Why? Because we are not specifying a particular network. Okay, if we are creating this, then we know that Redis is going to be created in a Docker 0 network. So let us create Redis. Oh, I've not exited from my busy box. Okay, I've created Redis. Now if I run inspect, if I run docker inspect, you will see that you will not see any Redis there, right? You will not see any Redis. There is no Redis. What you are going to see here are the our containers that we are running in our custom network, there is no Redis. But now we want that Redis should be part of this particular network. We want Redis to be part of this particular network. What can we do? Because here we can see that there is BusyBox, we can see that there is Nginx, but there is no Redis. This is BusyBox, this is Nginx. There is no Redis. So how can we add Redis? Here you can clearly see that BusyBox is there. You can clearly see that Nginx is there, but where is Redis? Redis is not here, which means Redis is not in our container, right? So how do we get Redis added? Let us try to see if we can get the ID of Redis. This is Redis here, that is its ID. Okay, let us copy the ID of Redis. Now to add Redis to our network, this is what we are going to do. We are going to run this command: docker network connect 1U and then the ID of Redis. Get it very well. Docker network connect, the network name, then the ID of that network of the container that you want to add. That is what you are going to do. So when you do this, you see that now if I run now docker inspect 1U, how can we see? We can see now that all the three containers are in the 1U network. This is the first container, this is the second container, this is the third container. So I have added all the three containers in the 1U network. But there is another thing. The Redis that we just added belongs to two different networks. It belongs to the Docker 0 network as well as in the 1U network. So question, can a container belong to two different networks? Answer is yes. Because we took the container from the Docker 0 network and then we added it to our custom network, which is the 1U network. So can a container belong to two different networks? The answer is yes, a container can belong to two different networks without any problem, without any trouble, I say. Okay, so this is the idea behind adding containers to networks and all the like. Let's see where we are standing. We have talked about the need for creating custom network. We have explained about the need for creating custom network, and then we have created our own custom network. Okay, we have created our own custom network. So now let us see how many types of networks are there in Docker and what are the different uses of those networks. Okay, now in order to know the different types of networks that are there in Docker, we have here the bridge, the host, the node, and the overlay network. Okay, the bridge, the host, the node, and the overlay network. That is how those are the different types of networks that we have in Docker. Okay, so in this type of situation, how can you know which ones are there? Here is the command: docker network ls. When I run docker network ls, it will give me the networks that are presently here. See, I have under this driver here, I have bridge, I have host, I have null, and then bridge is also my custom network is also bridge. Now look at something here. Now when we have an EC2 machine, and inside that EC2 machine there are containers. These two containers inside the same EC2 machine communicate with the network that is called bridge network. This is very important in the interview. They always ask it, what is a bridge network? EC2 containers in the same EC2 communicate using the network called bridge network. That means that what? Docker 0 is what? It is a bridge network. Docker 0 is a bridge network because these two containers communicate using Docker 0, and Docker 0 is a bridge network. Okay, that is the first thing about bridge network. So what is a bridge network? A bridge network is a network through which containers in the same EC2 instance communicate between themselves. An example of a bridge network is Docker 0, and Docker 0 is the default bridge network for Docker. So bridge is the type of network through which containers communicate together. Okay, that is bridge network. Now we have another kind of network. It is called host network. Host network. So let us first of all talk about the shortcomings of bridge network. What are the shortcomings of bridge network? The shortcomings of bridge network is that, number one, there will always be orchestration and scaling, which means there will be need for another EC2 instance. And if there is another EC2 instance and another containers are here, how will these containers communicate with this one? Because the definition of bridge network is that the two containers must be in the same EC2 instance. So if now there are two different instances, bridge network can no more hold. That is the shortcoming of bridge network. Bridge network can no more hold. Now there is another form of network called the host network. There's another form of network called the host network. What is the host network? The host network is a situation in which the containers in the same EC2 instance, instead of using bridge to communicate between themselves, they use the host network to communicate between themselves. You get it? Instead of using bridge, they use the IP of the host. They use the host IP, which means these containers do not have IPs of their own. They are communicating using the host IP. They are communicating using the host port. They don't have their own ports. Port binding will not even work here. The containers will not have their own port. They are going to use the host IP. So here the containers have a direct link between themselves. They don't care about the host. But here all the containers pass through the host. That means all of them are communicating using the host. Good. If all these ones are communicating using the host, first default is that, number one, they cannot communicate with other they have actually solved the problem that the bridge containers were having, because now from the host IP they are able to communicate now with the different ones. They have actually solved this problem. But solving that problem they are creating another problem. What is their own problem that they are creating? What is the problem that these containers are creating? They are creating the problem in that you cannot have two identical containers in the same host, because you cannot have a Nginx container here and a Nginx container here. If you have this one, let's say this is Nginx and this is Nginx, it is like what they told us in primary school, that 1 minus 2, it cannot go. You cannot have Nginx and have Nginx. It cannot go. So if this solves the problem of communicating between the two EC2 instances, it creates its own problem on its own, which that problem is two identical containers cannot be created. Two identical containers cannot be created. If you create the two identical containers, one will wipe off itself. Let's try it. So with respect to the host machine, if we run docker run -d -p, you see that we are actually doing port mapping here, and then -net. Now we are telling the container to use the host network. Okay, we are telling the container to use the host network. Let us first of all remove all the other containers that we have. Let us remove the containers that we have. Okay, now let us create a Nginx container under the host IP. Look at --host. When we wanted to create using our own custom IP, we passed but our own name. But now we are passing --host, means that Nginx should use but the host IP. Okay, it has been created. Okay, now let us run docker ps. This is Nginx running. We actually did a port mapping, but can you see any port mapping here? There is no port mapping here. Nginx does not have a port. It will still come back to the original port in which the image came with it, and that is port 80. So if you want to access the Nginx, although when we were creating the Nginx, we actually said it should map a particular port, but it did not map that port. It never mapped that particular port. There is no mapping here. Okay, and because there is no mapping here, what happens? Nginx now is going to be accessible through the original port. So if we go to our system, here is our system, and we take def, we take the public IP here, we will be able to access Nginx without using any port. We can access Nginx without using any particular port. We are just going to put the IP address of our host machine, and we'll be able to see Nginx coming on. You see, this is Nginx. Have you seen me putting any port here? There's no port, but Nginx is coming on. It's because we are using the port network. Okay, now if I decide now and I still create the second Nginx container and still use the host again, Nginx will not be created. It will not be created. Okay, let us try. This is another one. docker run -d --host nginx. Let us run again the container. You see what will happen. Copy. You see, it has been created, but when I run docker ps, what do I have? I have only one nginx. Only one nginx created right 2 minutes ago. Where is the other one that I've just created now? Where is the new one that I've just created? Let's run docker. Let's run docker ps -a. You'll see that you will see another second one that I just created just 29 seconds ago. It has exited. It exited, and the reason it exited was because there was a clash. There was a clash. It will exit because it is seeing that there is a nginx that is already existing using a particular port, so it cannot more create itself again. So that is the shortcoming of the host network. Okay, now we have the node network and the overlay network. I'm seeing 10:30. Can we continue?
We can do this too for the next class, sir.
That is just what I thought. So we are going to continue. We are going to continue from next class. I see some people, maybe some people have already even slept.
Yes, sir.
Okay, all right, let's continue. Let's do the node network and the overlay network in our next session. Good night to everybody.
One question, sir.
Yes.
Yeah, I saw there is a command you run and you put 3,800 seconds sleep.
Yes.
Why did you choose the container to sleep after that time, sir?
Because the container is it is a Unix container that is running. That is, it is an operating system.
Okay.
It is an operating system that is actually running like a machine.
Okay, so that was Redis. Okay, sir.
Yes, it is an operating system. Redis is a Unix operating system that is actually running like a standalone computer. So when you put that one, it means when you are not using it, it let it go to sleep.
Okay. Well noted, sir.
Yeah. All right. We meet maybe on Friday.